new company that's focused on enterprise AI solutions, putting deployment where data for enterprise settings. Before founding Aible, Arijit was a veteran of Harvard, the author of Classic Harvard, and he's also started a company called Beyond Core. Those are the people who read AI advocacy. Remember, Beyond Core was so Salesforce years ago, and he started. And those had to quickly deploy AI and safely deploy AI. I don't know if you're able to attend or take piece at our piece sessions. We have Dave Tucker from Microsoft tell us that how AI engineering cases video of the world, not then we have chat for leaders. And then that's about the taxes and absolutely AI bots. In fact, session and why I heard our demons for such unique seat servers. Yeah, were awesome.
Thank you. Hopefully you can hear me fine.
Yes.
Perfect. So we're going to cover a few different topics today. My key focus is how do you think about security as an inherent part of doing generative AI projects? And our focus has always been on how do we empower business users to create their own generative AI. In fact, the tagline of Aible has always been, I am able. And to do that, if you want to empower people, first you have to figure out how to secure the environment so they're not going to actually do things that will get you into trouble. So we're going to talk about 5 key things here. But the first one being, how do you create a walled garden? How do you create it in a way that is secure by design? The good thing is that most people are already beginning to think this through. If you look at what Google is talking about, what Microsoft is talking about, they have very much started with a very simple message of, hey, it's your data, it's your cloud, it's your reinforcement learning data. All of that is going to stay in your cloud. Now, be careful there because some of these organizations are saying, well, all that is true, but I'm still going to log all of your interactions, and I promise I won't look at it. And some are saying, no, we won't even log your interactions. It's completely under your control. So look into the contracting, look into the actual agreements you have with your cloud, and make sure you've turned on the right settings. But your design principle should be one where the code comes to the data. If you find yourselves giving data to a different provider, moving data to a different cloud to enable generative AI, you have a problem here. Your principle should always be, how do I put all of the code where the data already is? That's a more secure way to do it. The other thing we always recommend is deeply thinking through, do you have privacy requirements? So for example, we work publicly, United Health Group has talked about how they're working with us, the few other comparable companies that we are working with. One of their concerns was HIPAA. How can I avoid a situation where AI learns stuff about my data? In fact, you guys might or may not know this, that deep learning networks, forget about generative AI for a second, even just deep learning neural nets can memorize things like social security number. So how do I deal with a world where the AI might learn privacy governed data? The approach we took is we K-anonymize data before it goes to a deep learning network or goes to a generative AI system. K-anonymization is a very well understood technique where you basically say, I will not provide you information on number of observations less than K. So if I go in and ask a question like, what is the average age of people in this zip code who are male, who have this disease, the system will refuse to answer that if the count gets smaller than K. And the US government typically uses 10 anonymity as the way to anonymize data that they provide in public, like the HCUP data set. So what you want to do is, rather than your design principle being, hey, I'm going to teach my users how to do the right thing, you should design your system in such a way that the users can have a walled garden to work with it. And one of the key things we did in our architecture is we did this using infrastructure as code. So everything runs in the customer's VPC. There are other techniques you can use. Infrastructure as code was just the one we found was the most flexible, because it allows us to continue to maintain the models, continue to maintain the infrastructure. As new technology comes in, we can usually deploy the technology unless we need new permissions. So it actually allows us a lot more flexibility to manage the technology in the customer's own cloud without having to go through a lot of complexity. So we found it was the best way to have the benefits of the maintainability benefits of software as a service while the control benefits of enterprise code. But find your own way. Just make sure you have created a true walled garden. One way to think about it is, what best practices do your users have to follow if they don't risk your data? If the list of best practices is even one or two elements, you probably have a problem. The second thing to look at is when we are looking at many of our customers, so they'll have 100, 200, 300 use cases ready. But the approval process is slowing things down, because what they're doing is every project team has come up with their own technology stack that they want to use. One team wants to use this model, another team wants to use that model, somebody wants this vector database, somebody else wants that vector database. And all of them have to now write up an architecture document and get approved. So the approval process is making these use cases unmanageable. You don't want that. You don't want security to be a barrier to innovation. So what we proposed is, like, this is, for example, a slide from Anderson Horowitz on the left, where they talk about all of the components you need to have a large language model. Great. You need all those components. But can we templatize this? Can we come up with a general purpose in a combination of capabilities that are very flexible? And we'll talk about the flexibility in a second, but that are very flexible, but then have a consistent capability be brought up every time. Again, infrastructure as code is a good way to do this. We just created a template that just works. And every time a customer wants to bring it up, it's the same template that is getting deployed. Whether I'm doing a structured data use case or an unstructured data use case, whether I'm doing a document generation, whatever I'm doing, it's the exact same consistent infrastructure that is coming up. So the security audits, the architectural audits don't have to be done every time. Now, remember, one important thing also is that most work in generative AI has actually been done on document summarization, the left-hand side of this. And that is applicable to unstructured data. Unstructured data is more commonly available in the enterprise. 80% of your data is probably unstructured. But if you look at data by value instead of by volume, most of your most valuable data, your sales data, your inventory data, some of your supply chain data, all of that is actually sitting as structured data. And in the world of structured data, what generative AI companies typically had fallen down to is NLQ, natural language querying. That actually doesn't leverage all of the power of generative AI. Think of it as NLQ would be the equivalent of exact search in the world of document summarization. You actually want the structured data capabilities, again, to be consistent or comparable to what the unstructured data capabilities are. You want to be able to ask a question like, how can I improve sales? How can I reduce churn? These are not NLQ questions because these questions can't be translated to a SQL query. But these are exactly the kind of questions you want in a generative AI world. To do that, you need the equivalent of a vector database. So basically what the vector database does is you ask a vague question, the vector database understands the intent of it, understands which pieces of document snippets might be relevant for that thing that you're interested in, and then they set appropriate subset over to the LLM for summarization. You need the exact same thing. Our approach is something we call the Aible information model, where we look at billions of variable combinations very quickly, figure out which charts, which combinations of variables would be relevant to answer a question like, how can I improve sales? How can I reduce churn? And then send the relevant charts over. Again, very consistent with vector database. You should come up with your own abilities, but just think through. You can't just have a tech stack that solves just the structured data problem, or the unstructured data problem. You have to think through your broader use cases and make sure your generalizable stack truly is generalizable. Because if it's not, again, the exceptions will get in the way. You'll spend so much time doing exception handling, creating this standardized, reusable combination of technologies. It's just not going to, you're not going to get the benefit from it. One other important thing of having this as infrastructure as code and thinking through serverless techniques is that these resources are only coming up when they are needed. They're not sitting there and costing you money. That is another reason to do these things as infrastructure as service, especially in a serverless context, so that, yes, you're getting consistency, but you're not wasting money bringing up 50 duplicate systems up every time. So the Aible approach to this is very simple. When you go into Aible, everything executes in your cloud, and you can immediately just start asking questions. Your questions might be related to analytics, summarization. You could be doing document generation. Anything you are doing, the system figures out, oh, you are actually trying to do analytics. It'll come back and say, well, here are some data sets I see. Do you want me to answer the question based on this? You ask a question, it figures out, oh, you're trying to ask a question of a document. Here are the documents we see. Do you want to answer questions based on that? You can use multiple models. You can use multiple tones. The point is you get the complete flexibility of all use cases, and you can create custom use cases extremely easily by changing something called a chat template. But the point here is you have a consistent capability that is flexible. And that allows you to reduce both the risk profile and the approval, simplify the approval process. Because as long as they're using the pre-approved tech stack, they can just get going. They don't have to come back to the security team, to IT for approvals. The third thing you should be looking at is hallucinations. Now, a lot has been said about this, but one of the things I find is a lot of people still don't understand what hallucinations are. I've seen extremely senior people say completely nonsensical things about hallucinations, right? So let's get some of the facts understood first. First thing is hallucinations are real and they are high. If you look at the GPT-4 paper, it was about 75% accuracy in business, which means there was about a 25% hallucination rate. Now, one of the important things that they talk about is the way to solve this, according to the research paper itself, is that you should not use this in use cases where hallucination could be a problem. The second is, hey, you should have humans review the output to find hallucination. Let me point out that in the world of enterprise, neither of these are acceptable. Because if you go to any exec and say, hey, is accuracy in that answer important to you? They'll say yes. Is there a use case where accuracy is not important in the enterprise? Probably no. If I'm writing using ChatGPT to write a Valentine's Day poem for my significant other, maybe there it's okay to not be accurate. But in most enterprise use cases, you're going to very quickly find the lack of accuracy is not an acceptable situation. And this idea that a human being will double check it is just not tenable, because the volume of content that can be generated by generative AI, by definition, is inhuman. A human being can't possibly double check a machine. Just the scale, the orders of scale in productivity are completely different. So these techniques will not work. The other thing that you'll hear from people is, hey, we grounded the data set, we did grounding techniques, and now we don't have any hallucination. Grounding reduces hallucination. It's a very useful technique. Grounding does not eliminate hallucinations. Or you'll hear from people, well, I'm just doing NLQ, and the system is generating a SQL query, and the SQL query is executing and giving me the answer, so there is no hallucination. No, because the NLQ that got translated into the SQL, hallucination could have happened at that point. So the answer you're getting is not the answer you were expecting, and you don't know because you asked the question, the system gave you an answer. The fact that there was a hallucination in between the question you asked and the answer the system gave you, you may not observe that. So hallucination is a real problem. There are techniques to reduce it, but do not take it as a solved problem. Any expert who comes and tells you it's a solved problem, either they are about to get the Turing Award or they're basically BSing you, and they don't know that they're BSing you. Now, we took a different approach. We said, look, the problem with hallucination is really one of false positives. business users really don't understand what a false positive means. If a system very confidently gives them an answer, they assume that answer is correct. And thus, what we should do is, yeah, of course, the system is going to, we give the information to the generative AI saying, here are the things we want you to summarize. We, of course, do things like grounding the LLM. For people who are using, hosted LLMs, we do things like masking, K-anonymization, all of that. But when the response comes back, we use a deterministic AI. It is still it's an explainable AI, basically, right? It's something where you can go understand what the AI is doing, but we use a deterministic system to go in and double check the output. Now, understand this. Such a system can tell you whether output was correct. It can go and confirm the facts in the data. What it cannot do is tell you when the output is incorrect. Again, you don't want to make too big of a claim. You only want to make the claim that is scientifically correct. The scientifically correct claim you can make in this circumstance is, I had a system double check the output. In this case, the user asked a question. Everything highlighted in blue has been double checked by Aible, and we are saying these things are correct. And we can bring up a chart or a snippet from the document that has never gone through generative AI to show you why the double checking system thinks that the output is correct. What we've done here is anything that is not highlighted in blue, I cannot say that it is wrong. All I can say is my double checking system couldn't confirm it. But to a business user, that is sufficient. What business users want is absolute clarity on what they can rely on. So anything that is highlighted in blue, they can rely on. They can triple check it by just putting their mouse on top of it and seeing the raw data. So what you're creating is a world without false positives. Yes, there will be false negatives. There will be cases where something is true, but the system will not highlight it as blue. I cannot guarantee that will not happen in this kind of an architecture. But that's a much smaller problem, and users can go in and just say, hey, you know what? Worst case scenario, the parts that are not highlighted in blue, I'm back to the world of normal generative AI, which is I need to double check it. But you have taken that problem from something insurmountable to something which is much more manageable for the human. Another important part of this is that the information that comes up on the right-hand side has to be factual. So if we bring up a chart, there is literally a Python code corresponding to that chart that's sitting around and getting logged in your cloud. If a regulator comes in and says, how did you take this decision? What was the basis of this decision? You need to have a log of what was the chat response, what was the decision taken, what was the actual raw data, how did we get to that decision? And if you don't have that, in anybody who's in a regulated industry, you're going to have issues. And I have a feeling there's a lot of regulations are going to come into the space. So it is better to design your systems with expected regulations in mind, as opposed to, build your system, go execute, and then you find out, oh, shoot, this regulation came in. And one of the most obvious regulations that's going to come is, can you track a decision back to the original data all the way through the steps of the system? If you can't, you're going to have problems. The next thing after this is this idea of monitoring. And one of the things I'm really getting concerned about is a lot of guys are looking at things like, hey, people might put in prompts to hack our system, which is a big concern in the world of consumer-oriented generative AI, because of course you don't want somebody to hack the system and do something illegal by using your generative AI system. In the world of business, though, putting too many constraints around a system is actually a bad idea. Because, for example, let's say somebody has anomalous prompts. So anomalous prompts for us could very well be a case where somebody was trying to hack the system in doing something that it shouldn't. For example, the New York Times journalist who got the AI to fall in love, claimed that she fell in love with him. Well, all the AI was doing was trying to answer trying to give back to the user what the AI thought the user wanted, right? So that is a case that would show up as anomalous. But we also found that some of our more creative prompt re-engineering that our team was doing also shows up as an anomaly. So if you put in these kind of walls and you say, hey, I will not allow you to put in anything anomalous, you're actually going to have a problem. You're going to kill innovation. So don't put a constraint around it. Turn that into a monitoring capability, because you're in the enterprise. If you're in the enterprise, you can then find the people who are doing the wrong things and turn off their access. But don't assume that an anomaly is a bad thing. Similarly, you want to monitor every use case, every model across clouds. You want to do it in a consistent way, because you want to quickly innovate. You want to try, you want to do A/B testing. You cannot have a situation where you have one monitoring system for Palm and Google, another monitoring system for GPT-4 and Azure. Why not Palm 2 with data in Azure? Why not any other combination? So you have to have a system where you can monitor the information at a very granular level of detail, at the level of the user, at the level of the model, at the level of the use case. Look at positive feedback, negative feedback, get all of that information in a consistent place. And we'll come to this in the very next second, but a lot of this feedback is a major corporate asset. So we'll come to that in the very next slide. So user feedback. I think most people are massively underestimating the importance and value of user feedback. There used to be a common debate in this space, which was, is it about the model or is it about the data? If I have more data, am I better? If I have a better model, am I better? I actually think in the current situation, the better the user feedback, the better the system. In fact, one of the things you'll find is many of these models have gotten big enough that a little bit of few-shot learning actually can give you a really, really good response. Whereas if you go in for a heavyweight reinforcement learning, basically I'm going to train the AI to make it specialized on my data. By the time you've done the exercise, you're not getting that much benefit over just few-shot learning, but you have now locked into one model. Whereas the models are changing so fast, by the time you're done with your whole reinforcement learning project, a better model might have just come in. There are many techniques that are much more flexible. And at this moment, I would focus on flexibility. And that feedback, the user goes in and gives you feedback, that information is your corporate asset. You don't want that information to be sitting in a LLM. You want that sitting in your environment so that you can reuse that information across LLMs. So when you do your design principles, make sure that it is very easy for users to give feedback. In fact, one of the things we do is we make sure that a generative AI project from start to finish takes just a matter of minutes. So a few minutes after starting with a project, we can get something in the hands of many, many business users. So business users can start providing feedback in context. As you saw in this video, they can literally go in and look at the chat response, edit it, and give you a better response back. Why did we do this? Because the easier you make it for the business users to provide you feedback, the more valuable information you're gathering from the system. Today, the state of the art for many of these projects, and many of you have gone through this, is the data scientists go to business and say, hey, could you give me some good examples of good interactions, bad interactions? Let's create a nice little Excel spreadsheet with all these examples, and then we are going to do something with it. Well, the business user is being asked to give feedback out of context. They are trying to imagine what you're asking for. They're trying to give you the best possible information. Sometimes people just outsource this and they say, hey, outsourcing vendor, give me some good examples. Well, the outsourcing vendor doesn't actually understand your business as well as your business users do. So the goal should be to make it extremely easy for the actual users to get their hands on a good enough starting point, not the best starting point, just a good enough one, and start providing feedback in context. And then keeping that feedback secured in your cloud in a way that is portable. So I can, if let's imagine I'm doing a project with GPT-4 and I've gotten some great feedback on it, tomorrow I decide to move to the next evolution of GPT or the next evolution of Palm, next evolution of Anthropic, take your pick. I should be able to take all of that reinforcement learning information and move it over to the next model. So design your systems for ease of collection of this information and security of it. Now, people always ask me, what are good use cases? What I really tell people is, We're in the early days of generative AI. Just get it in the hands of business users. We've given you some examples by industry, by role, but the reality is your users will find the right use cases for you. As long as you make it extremely easy for them to use, you make it flexible, you make it possible for them to go from structured to unstructured to generation to whatever they want, you'll make it possible for them to combine structured and unstructured. You let them do flexible things, build their own solutions based on the building blocks. You'll be very pleasantly surprised by how many use cases can be done very, very rapidly. So a few weeks back, we were speaking at the AI4 conference, and one of our customers, Sienna, spoke there. And they were talking about how they're iterating on use cases with their business users in a matter of minutes. And the key point was that reduces the fear of failure. If you can do these iterations in a matter of minutes, then failure is not failure. Failure is just something I've learned. Whereas if a project takes 1 month, 2 months, 3 months, and then it fails, that's really a failure. So get shifted to trying new use cases in a matter of minutes. We actually encourage our customers to get things done in about 3 to 5 minutes. After those 5 minutes, get it in the hands of business users, let them provide feedback. And these are some of the things. You can go to Gartner peer reviews and take a look at some of the feedback we have gotten from our customers. This approach of doing the things may sound very strange. What the heck do you mean I should get generative AI projects done in 3 to 5 minutes? What the heck do you mean I can do this without having a lot of data scientists and IT involvement? Well, the proof of the pudding is in the real examples from real customers. And if you're looking at vendors today, don't just go by 1 or 2 codes. Go figure out what the actual use cases are. Have they done it at scale? Have they done it at major companies? Because if they haven't done that, they actually haven't gone through the security issues. They haven't figured out how to deal with the real enterprise constraints that generative AI faces. You guys will have access to the video. There are a lot of links on that, on the PowerPoint that you should be getting from them. Otherwise, just go to aible.com and you can get all the information there. And of course, please follow up with Yuda and you can get more follow-up information from him as well. I don't know whether we have the ability to take questions. I'm happy to take some if you have any. It might be safer if somebody in the room just copies it into the chat in case the audio quality is not so good.
And, really keen on finding out more that that's very experience together. It's fun. I think it's really interesting. The idea of going as minutes is amazing. And you do it safe with all the caveats that we know. It should be amazing. I would like to, we're up on the time, but I would like to allow for a question or two if there are any in the room. Any questions? Yes, please, go ahead. Feedback.
Can you hear me?
Yes, I can.
All right, perfect. So amazing use case, I think. One of the things that I was thinking about, particularly, this is a product that can actually digitize business knowledge and can potentially be applied to business succession planning. Like if you're really getting old and you want to, like, just thinking about it, many people who get old and they want to like find the next successor, and then they're kind of worried about, hey, you know what, is this guy going to be able to pull it? Very common use case. So I think it's a great use case that you've built. And the question is, how do you deal with data silos in an organization, right? Because one of the most common use cases is that the HR department is headed by someone, forgive me, Jack. So from Amazon, I mean, he has an Amazon relation, and they might have about AWS, and there might be a different organization, a sub-organization or a business unit, which is a Microsoft shop, right? Totally different data sources. So how do you deal with moving the code over to disparate data silos? That's my question.
No, I love your question. I'm going to answer your second question, then I'm going to come back to your first comment if you don't mind. But to the question, what we do is we say, look, build AI where the data is, and then let the AI communicate. Let me give you a real example we just did. So when an order comes in, this customer was concerned about whether they're going to have inventory stock out because they were having some inventory stock out. So they wanted when the order to come in, if there is a risk of stock out, give the seller a recommendation saying, don't sell what the customer is asking for, sell them an alternative, right? And they were concerned about being paid. So they wanted to predict right then and there, how likely is it that the customer is going to pay me so that I don't give scarce inventory to somebody who may not pay me, right? Completely three different systems, right? Finance, inventory, and sales. If we tried to integrate the data, it would have never worked. We just created a predictive model in the world of inventory stock out. We created a predictive model in the world of finance. In both cases, the code was generated where the data was, and we created a generative AI experience in the world of sales, right? But you're using the AIs, you're letting the AIs talk to each other rather than trying to get the humans to allow the silos to cross or letting IT to have the silos cross. Now, going back to your comment, by the way, you said something very perceptive I talk about it quite often. Think of AI as a way to create institutional knowledge out of individual knowledge. And that is true of all AI. That is true of predictive models. That is true of generative AI. What you're doing is when you're taking that user feedback, when you're collecting that information, you are really taking individual knowledge that is not accessible to others and turning that into institutional knowledge that is available to all. And that is why, AI needs us more than we need AI, to be very funny. It's really true. One of the chapters in my book is all about AI needs us more than we need AI. But when we collaborate, when we actually kind of give ourselves superpowers by being empowered by AI and give our knowledge to the AI so that it can scale, wonderful things can happen.
Awesome perspective. Unfortunately, we're running out of time, but I would love to have more conversations. So I'll give you a minutes and we can chat some more and then move to our next event for more conversation. With that, thank you. A big applause for